Do you all know, or have you ever heard of Gödel's incommensurability theorem? This sounds daunting and disturbing. Have you ever heard of this? Does anybody have a clue what I'm talking about? Okay, well, that in itself is a measure of the kind of society we're living in, because to my mind, more important than Einstein or Schrödinger or any of those people was Kurt Gödel, German mathematician. And he began by studying the calculus, and he had a very funny method. What he did was he would number every operation in a partial differential equation. And these numbers are called Gödel numbers. G-O-umlaut-D-E-L, Kurt Gödel. And what he showed, and I think this is maybe the most important intellectual step taken in the 20th century, he showed that any formal system will produce true statements which are not provable within the confines of the formal system itself. Now, what this actually means is that mathematics can fail. It means that there is no closure. He proved this logically, showed that closure is impossible, that everything, he showed it for arithmetic, the most secure of all intellectual edifices. Essentially what he showed was that 2 plus 2 equals 4 is a very strong tendency, not a law. And this incommensurability theorem means that no program of formal analysis will ever completely exhaust its subject. There will always be a residuum of mystery. And we need to come to terms with this. I mean, it's taken us 80 years to get Einstein under our belts. And that's a simple notion compared to what Gödel is saying, because what he's saying is not about, the distortion of space-time near massive objects, but something which actually affects our own lives on a day-to-day basis. Wittgenstein used to say, we do not seek statements which are true. We seek statements which are true enough. That's this genuflection to the incommensurability theorem. That's as good as it gets, folks. True enough. Beyond that, there's just, the airy realm of metaphysics, which will never be plumbed. So what we're trying to do is refine our model, make it more responsive to what we want the model to tell us. But you don't want to confuse the model with the phenomenon being modeled, because it will always have dimensions which exceed the grasp of the theory. I think that in a sense probability theory has made it almost impossible for us to think clearly about anything, because it contains certain insidious built-in assumptions that are purely assumptions. For instance, probability theory tells you that when you flip a coin, the odds of it being heads or tails are 50-50. If, in fact, that were true, the coin would land on its edge every single time. So what we need, you see, is not a theory of what is possible. That's science. If you want to know if something is possible, you find a scientist, and they're always perfectly happy to fulfill this function and tell you whether this is possible or not. What we completely lack as a civilization is a theory that explains to us how it is, out of the vast class of possible things, certain things undergo what Alfred North Whitehead called the formality of actually occurring. We have no theory. I mean, science can say, well, it's probable that it'll be this, but it's also 40% probable that it'll be that. You say, well, which will it be? You say, well, I just told you the probabilities. Say, that's not good enough. I want to know. Say, we have no theory of selecting among the probabilities. Another thing probability theory says is that chance has no memory. And so they always, in first-year statistics, they say, if you flip a coin and it comes up heads 49 times, what are the odds it will come up heads the 50th time? The answer is 50-50. But any gambler would tell you that, if it comes up heads 5 times in a row, bet on heads, for crying out loud. The other problem that haunts probability theory is that it assumes that time is an absolute flat plane. It assumes that no physicist tells you in his lab notes, please perform my experiment on Tuesdays, Wednesdays, and Saturdays, because it won't work any other time. In other words, the assumption is made that the experiment will produce the data predicted by theory no matter when the experiment is performed. In other words, it's assumed that the phenomena is time independent. But that's just an assumption that Newton got into. Proving that phenomena are time independent is absolutely beyond our intellectual reach. It can't be done. A curious thing about probability theory is, say you want to know how much current is flowing through a wire. Here's how probability theory finds out. It measures the current flowing through the wire with a meter. It measures it 1,000 times. It takes those values and adds them together. Then it divides by 1,000. Then it tells you this is how much current is flowing through the wire. You look at the value they've given you and you say, but we took 1,000 measurements and we never got this number. Say, well, that's because, you didn't average the probability. And, well, if we took 1,000 measurements and not one is the value you're offering, why should we believe that this is the amount of current flowing through the wire? Well, then there's a bunch of hand-waving and epistemic foot stamping and so forth. Science is an incredibly fragile edifice, which if it weren't for its ability to hand its findings on to technologists who make pretty things, it would have to take its place somewhere to the left of, homeopathy, acupressure, something like that. In other words, it is not a meta-theory. It has not got truth by the jugular. It has a bunch of fishy mathematical formula which it's flailing you with. But I think that serious revision of probability theory is going to have to take place.